Hello everyone, I'm Kalawa and this is Made Simple with Us. Today again we are moving on to another topic in matrices. So today we are going to discuss on the inverse of 2 by 2 matrices. And don't forget to subscribe to our channel and always hit the notification button so whenever we publish a video like this you will be the first to know. So let's dive in. The inverse of a matrix is A is written as A inverse. And then the general formula for the inverse of the matrix is always equals to A inverse must equals to 1 divided by the determinant of A multiplied by the adjoint, or we can say the cofactor. So from this formula, remember in our previous video, I said whenever you see sign like this, note that that sign is determinant of that particular given matrices. So from the formula, this sign is the determinant. So we are going to follow some steps or rules in order to solve the inverse of any given matrices. So for example, let's say we are given the matrix A. This is the matrix A and the elements are given, which are A, B, C, and D. And then they ask us to find the inverse. The inverse of A, matrix A. So if we are given a short question and we are asked to find the inverse, remember the formula is saying the inverse of A must equals to what? 1 divided by the determinant of A multiplied by the cofactor or the adjoint. So the first rule here is we are first going to determine the determinant of that matrix. And remember, the determinant of 2 by 2 matrix is just as the same determinant in which we solved for in our previous video. So go back and watch our previous video if you want to know on how you can find the determinant of 2 by 2 matrix. So it's just the same procedure. So the first rule is you say what we find. The first rule or first step, we say we find, or say we determine, or let's just say find. We find the determinant of the matrix. So how are we going to find the determinant of the matrix? More especially 2 by 2 matrix. So remember, this is the matrix A. Say is equals to. Let me use white. A is equals to A, B, C, D. So we are going to find the determinant. Just from our previous video, we said to find the determinant of 2 by 2 matrix, we multiply the corresponding elements. That is 8 multiplied by D, and then B multiplied by C. We subtract there. So this is going to be A determinant is going to be A multiplied by D minus B multiplied by C. So this is going to be now AD minus BC. So this is the first step we are going to follow. This is the first step. So after we have ascertained, or we have arrive at our determinant, the second step is saying that step is saying we should interchange the position. Let me just write it this way. The second step is we interchange the position of A and D. A and D from the given element. From the matrix elements. That is, from these elements, okay, let me just write it this way. That is, from these elements, from the matrix A, remember the elements are A, B, C, D. A, B, C, D. So we are going to interchange the position of what? A and then D. So if we are to interchange there, this is going to be the A matrix must equal to where we see A, we are going to replace the position. So this is going up. It's going to be D. And it's going to be A. And this one still remain in their position, that is B and C. They'll still remain. So this is the second step. This is the second step. We have to interchange A and D. Remember, in some case, it's not always in letter form. Even if there's a number here, you interchange it to number. Okay, we are going to solve problem on that, and you can see. Now, the third step is saying that we change the sign of B and C. The third step now is saying we should change the sign of B and C. B and C. That is from the elements again. From the element of the matrix. So again, let me take again the original form. So A is equals to A, B, C, D. Remember, the second step is saying we have to change the sign, right? So this is it. So A must be equals to now. So if we change the position now, that is second step, that we should change the position for A and D, between A and D. So this is going to be now D and then A. So now this third step now is saying that we should change the sign of what? B, and C. So meaning if here is positive, they will change the sign, it's going to be negative. So this is going to be negative and this is going to be negative. So this is going to be written as now minus B minus C. So this is the third step. Now the final step is saying now that we should multiply this matrix by the cofactor, or we call it the adjoint matrix. So the first step now, the fourth step, or let's say the final step now, is saying that we are going to now multiply That is, we are going to multiply, and just write it this way. We now multiply the new matrix, that is from step from step 3. That is this matrix now that we have ascertained now from step 3. We are talking of this, and from step 3, we are going to multiply this by the inverse formula, which says 1 divided by the determinant of A. That is, remember, from this formula we have arrived at the determinant to be AD minus BC. So we are going to multiply it. So this is going to be now 1 divided by, what's the determinant for A now? It is AB. No, it's not AB. It is AD minus DC. Minus BC. So this whole thing is going to multiply by the new matrix. The new matrix now, this could be now the cofactor, or we call it adjoint. The adjoint. So these are going to be D minus B minus C, and this is A. So this is the formula for the determinant of 2 by 2 matrix, and these are the rules you must follow. So now let's take a problem and let's see how it works. So for example, let us take a problem. Example, we are asked, example, say find the inverse of the following matrix. Go at figure 1. Let's see, we have A matrix to be 1, 2, 3, and 4. On figure 2, we have B matrix to be, let me just take randomly, 3, 1, 2, and 5. So this is B matrix. So we go, and then on figure 3, C matrix is going to be now 3, 5, minus 2, minus 4. And let's take for the final one, D matrix is going to be now 4, minus 3, minus 6, and 5. So this is it. So from this example, I'll only solve 2 solutions. Okay, so let me start with D. So matrix D, the elements are 4, minus 3, minus 6, and 5. And this is 2 by 2 matrix. So remember, in order to find the inverse of 2 by 2 matrix, let's indicate the formula for inverse of 2 by 2 matrix. See what the inverse of 2 by 2 matrix is. That is A inverse must equals to 1 divided by the determinant of A. But in this case, we are dealing with D. So let me just use D, the inverse, and this is D, multiplied by the cofactor, or say the adjoint, or the adjoint. So remember, the first step is saying we should first find the determinant. So rule 1, let us find the determinant. The determinant of D. So the determinant of D that is going to be, let's take D out. This is 4, minus 3, minus 6, and 5. So we are going to find the determinant is going to be, the determinant for D now is going to be 4 multiplied by 5 minus into minus 3 multiplied by minus 6. So 4 times 5 is going to give us 20, minus 3 times minus 6, 3 times 6, 18. Minus times minus is plus, so this is going to be 18. And then 20 minus 18 is going to give us 2. So the determinant of D is 2. So hence, we are going to write this as, remember, 1 divided by what? 2 is the same as from the formula that says 1 divided by the determinant of D. And the determinant of D here now is 2. So that's why we write 1 divided by 2 here. So we have cleared this one. This one is clear. What is left now? To find the cofactor. In order to find the cofactor or the adjoint, we say that is step 2. Now let's just say for me to determine the cofactor. The cofactor, we say the adjoint, or the adjoint from the matrix D, and the elements are 4, minus 3, minus 6, and 5. This is the element. So determine the cofactor here now. Remember, the first step is saying that we should interchange these two corresponding elements, A and B and D. That was the formula. But in this case, we have numbers now. So therefore, we are going to interchange 4 and 5. That's the first step. We do the interchange. Interchange. So this is going to be now. D is going to be. So this is going to be replaced by 5. And this is going to be 4. And then minus 6. Minus 3. So that's the first step in determine the cofactor. So the second step is saying we change the sign of the other corresponding element. So we change sign from the other corresponding element. That is, from this element, remember, if we are going to change the sign, it's already in negative form. So we are going to change the sign, going to be positive. So this is going to be, we still continue with what we have already ascertained from the first step. That is 5, and then this is 4. So if we are going to change the sign now, this is going to be 3, because minus is there already. Minus is here, and this is minus. So if we are going to change the sign, it's going to be positive. So this is going to be positive 3 and positive 6. So we have dealt with that. So this is now what? The cofactor. So we have now determined the cofactor. So we have now determined the cofactor. So from this now we can simply arrive at our answer. So from the formula, we say that the inverse A inverse, okay, let me use this. We say that D inverse must equals to 1 divided by the determinant of D multiplied by the cofactor. And remember, we have already ascertained all these elements, so now we just need to input them into the formula. So what is our 1 divided by the determinant? It is now 1 divided by 2 multiplied by, what is the cofactor? This is the cofactor now. 5, 3. And then we have 6, 4. So this is the cofactor. So we do the multiplication now. We're going to multiply this. That's why I said matrices is a continuous process. Remember, when we start the multiplication, this is just as when we have a scalar. Remember, this is now, it has now summed up to a scalar matrix. So this is scalar. So you multiply the scalar into the element of the matrix. So this is going to be now 1 upon 2 multiplied by, so each element of the matrix by 5, and then 1 upon 2 again multiplied by 3, 1 upon 2 again multiplied by 6, 1 upon 2 again multiplied by 4. So this is a scalar matrix now. It has now lead us now to a scalar matrix. So we continue again. So this is going to be now 1 times 5, this is 5, divided by 2, and then 1 times 3 is 3, divided by 2, and then 1 times 6 this is 6, divided by 2, 1 times 4 this is 4, divided by 2. So let's look again which number can be divisible here. 2 divided by 3 you cannot, because it can, but it can lead us to a decimal. So we leave it like that. So this is going to be now 5 upon 2, and this is 3 upon 2. They are going to give us decimal, so let's leave it like that. But 6 divided by 2, 3 to the 7, 1 times into 6, 3 times. 3 to the 7, 1 times into 4, 2 times. This is going to be 3, and this is going to be 2. So this is the inverse of a matrix. So this is the inverse of the matrix. This is the inverse of the matrix. So now let me take again, remember I said I'm going to solve 2 examples. Let me take example, let me take 2. Now let me take A. That is 1, 2, 3, and 4. Okay, let me take the A part. So A again is going to be 1, 2, 3, and 4. And then they ask us to find the determinant. We follow again. Let's write the formula. Always write the formula. So it's going to be, they've asked us to find the inverse. So this is going to be the inverse of A must equals to 1 divided by the determinant of A multiplied by the cofactor. So always write down the formula. So and then after you have written the formula, you find each element in the formula in order for you to arrive at your answer. So then let's find the determinants. So the determinant is going to be A. The element is 1, 2, 3, and 4. So this multiplied by this minus this multiplied by this. So this is going to be now, the determinant of A is going to be 1 by 4, 1 times 4 minus 3 times 2. So this is going to be 4 minus 3 times 2, 6. So this time is going to be 4 minus 6 is going to give us minus 2. So the determinant now is minus 2. So in other words, we have already ascertained 1 divided by minus 2, which is also the same as 1 divided by the determinant of A. That's it. So we have arrived at one aspect. The next aspect now is the cofactor. So how can we arrive at the cofactor? The first step is we say what we interchange the first corresponding element. That is from the question. From the original question, we have what? A to be 1, 2, 3, and 4. So we are going to interchange 1 and 4. So this is going to be now, we do what? Interchange. We interchange them. So this is now going to be 4, 1, and we still maintain the other corresponding, which are 2 and then 3. So this is the first step. The second step is saying we change the sign of the other corresponding element. We change the signs of the other corresponding element. That is, we are going to change the sign, and this is going to be 4, 1, that's maintained. So these two elements now, we change the sign. This is going to be minus 2, and this is going to be minus 3. So once we have done with this now leads us to the cofactor. So this is the cofactor. So we have now derived each element from the formula. So let's take again the formula and see. So the inverse of A was equals to 1 divided by the determinant of A multiplied by the cofactor. So what is the 1 divided by the determinant? We have arrived at 8, and this is the answer. This is going to be 1 divided by, what is determinant? Is minus 2 multiplied by, and this is the cofactor. It's 4 minus 3 minus 2 and 1. So this is cofactor. So this cofactor now, from formula, it has now lead us to a scalar matrix. So therefore, since it's a scalar matrix, we multiply the scalar by each of the elements in the matrix. So this is going to be now 1 divided by minus 2 multiplied by 4, 1 divided by minus 2 multiplied by minus 2 again, 1 divided by minus 2 multiplied by minus 3, 1 divided by minus 2 multiplied by 1, to multiply each of the elements. So this is going to be 1 times 4, this is 4 divided by minus 2, and this is going to be minus 2 divided by minus 2, and this other one is going to be minus 3 divided by minus 2, and it's going to be 1 divided by minus 2. So let's see if anyone can be divisible here. Yes. Minus 3 to itself is minus 1, into 4 is minus 2, so this is going to be minus 2. This cancels this, and this is 1. For this one, they cannot be divisible at the same sign, so minus divided by minus is plus, so it's going to be 3 upon 2, and this is going to be 1 divided by minus 2. So for mathematical purpose, we always write the minus sign not from the denominator. Let's put it from the division sign. So this is the answer, and this is how you solve for any given 2x2 inverse. And this is Madesimplewithus, and I'm Kalawa. Till we meet again for the next video on how you can solve for 3x3 matrix, and how you can find the inverse of 3x3 matrix. That's our next video. Tata.